Hi everybody, it's me Joe the Coding Maniac, and in today's video I'll tell you everything you need to know about normalization of data. So what is that? Normalization or feature scaling, as it is also called, is the process of converting all input values to a common scale, usually something between 0 and 1. But why do we need to do it? It is not always a good idea to normalize your data, since you are losing information about minimum and maximum numbers. But often it is a good idea. For example, machine learning algorithms such as linear regression or support vector machines will typically converge much faster on normalized data. On algorithms like k-means or k-nearest neighbor, normalization could be good or bad, depending on your use case, since here the distances make a difference. So without normalization, some features may have a greater influence to the outcome than others, and it depends whether this is good or bad for your model. How is this done? Well, there are many different algorithms as usually, but we will have a look at two of them that are very often used. Those are standard scaling and min-max scaling. Min-max will put the values in a range between 0 and 1. The standard scaling will try to normalize the data so that it has 0 mean and a standard deviation of 1. But now let's have a look at the code and let's see this in action. Alright, this is the code. So let's step through this. Again, the usual imports, we'll be using Scikit-learn as usually. And now we will define two helper methods, or functions in this case. First, a timer function that will help us to tell how long the fitting of a model took. And we have also a helper function for building our models. So what this function does is it does the training test split. It builds our model with linear regression algorithm, uses the timer helper function, and returns the test features and the test target vector as well as the model, so we can do predictions on it. We will use the Boston dataset, which is provided by Scikit-learn. I did choose this dataset because the value of the features is, there are pretty big differences, so it's a good example for normalization. We will print a description of the dataset so you guys see what this dataset looks like, as well as we will see the distribution of values for the features of the first data sample. Then we will define our normalization algorithms, so the min-max scaler, and we will transform the Boston data, and we will print it after the transformation to see the change in the data values compared to the one without the scaling, and then we will also see the difference to the standard scaler, which we define here, as well as printing its value distribution. And then after we printed the values before and after the normalization, we will also build models and see how long the fitting will take without and with the normalization, because I said earlier that the fitting will be faster for linear regression after we applied the normalization of data. So, well, we'll see whether I live up to this promise or not. Alright, this is what this looks like. So, here's the description of the dataset. there are 500 instances with 13 attributes. Yeah, you guys see it's a data set about houses in Boston. So yeah, basically you can read it. It doesn't matter actually, but what does matter is how these values are distributed. You see that there are very, very small values as well as very, very big values. So I think it would be a good idea to normalize this data to have it on the same scale. So after doing the min-max normalization, the values look like this. As you see, those values are now in between 0 and 1. For the biggest value of all is a 1, and the smallest value of all of them is the 0. And all other values are distributed in between that. Now let's have a look at the standard scalar. As you guys see, those values aren't distributed between 0 and 1 because this normalizer follows other rules, as I mentioned previously. Okay, now we have seen how this data looks like before and after being normalized by the different normalizers. But how does this normalization affect the fitting of the actual models? So let's have a look at that. So without normalization, the fitting took this amount of time, like 2 milliseconds. Oh, what is this? Yeah, doesn't matter. And the mean squared error is 22. After applying the min-max normalization, the fitting was much quicker, and the mean squared error is the same. Also, after the standard scaling, the fitting was also noticeably faster. And yeah, the mean squared error is still the same. So as I said, for some algorithms it makes a difference whether the data is normalized or not. Whether it's a good idea for your specific use case, you will have to decide this on your own. But I hope this showed you the difference that normalization makes at least on the speed. That's it for today's video. I hope you enjoyed it. If so, please subscribe to my channel, leave a comment, follow me on Facebook, do whatever you want. As long as I see you the next time, see you then.